Hello again, and this is the second of my revision videos on the normal distribution, where we're going to be looking mainly at using the inverse normal function on the calculator, where we're given a probability and we need to work backwards. So to warm up, we're just going to have a look at a more of a problem-solving question to do with the normal distribution. So I'll let you have a read of it, but we've got an IQ test applied to a population of adults. We've got a normal distribution X with a mu of 100 and a variance of 15 squared. Adults scoring more than 140 are classified as genius, and then we're asked to find the probability that an adult chosen at random achieves this genius classification. So what I'm going to do, as I tend to do with my normal distribution questions, is sketch what the normal distribution looks like in this case. So our mu is 100, so there it goes, right in the middle. Here is my, again, beautifully drawn bell curve, as you can see. And we're being asked to find the probability of scoring more than 140. All right, so I'm going to mark that 140 on the graph. It's to the right of 100 there. Obviously, it's bigger than 100. I just label that. So we've got 140. And the area in which we're interested is shaded in green to the right of the 140. So this is the probability that I'm interested in. So writing it out in the notation, we've got our distribution X, normal distribution 115 squared. I tend to just copy the question for some of this. And we're looking for the probability that X is greater than 140. So what's the probability of an adult scoring more than 140? So again, straight back to the calculator. If you're using ClassWiz calculator, you're going to be going to menu 7, option 2 for normal CD, as we went through in the last video. The lower limit of this is going to be minus 100,000. Again, we're finding the area between minus 100,000. Oh, actually, we've gone greater than 140. My apologies. So the lower limit is going to be our 140 here. And our upper limit is going to be our 100,000. Okay, so just to repeat, because obviously I said it wrong to begin with, the lower limit this time is 140. The upper limit we're going to set as 100,000 so that we find the area between 140 and 100,000. In this case, our sigma value is 15. Remember, the sigma is the standard deviation. The variance is 15 squared. The standard deviation, therefore, is 15. And our mu is, as we said, 100. So the probability of this happening is 0.0038 to 4 decimal places. So a very small probability you have of scoring 140 or more in this test. Oh, we've been asked to do it to 3 significant figures. So 3, 8, 3, there we go. 3 significant figures on the end. That's me falling into the trap of always doing 4 decimal places, but 3 significant figures is what we were asked for. Okay, so here is something interesting that happens at the end of this question, and this is quite common in a normal distribution question, is they say, okay, can you understand how to use that result? So we're told that 20 adults take this test. Find the probability that 2 or more are classed as genius. Now, the first thing that I'm noticing about this is that we have this statement of fact that 20 adults are taking the test. All right, it's the first thing that I'm noting. That means that we have a number of trials. We have a number of, times through this. And so this is suggesting to me that we're going to have a binomial distribution. So I'm going to think about that. And what would this binomial distribution be? So I'm going to call it Y rather than X because I've used X already. A binomial distribution where we've got 20 trials. That's the 20 adults taking the test. And then if I was to think, right, what is the probability here? Well, what's the probability that 2 or more are classed as genius? So classifying as genius seems to me to be our success criteria. Okay, if you remember binomial distribution, you have success and not success. So the probability of being classified as genius is what we worked out in the first part of the question. So we've got 0.00383. And so this then, although it's a normal distribution question, is throwing in a binomial with us. So if we're being asked to find the probability that 2 or more, that's the probability that X is greater than or equal to 2, which if you're using the CG50 calculator, you know how to do. You can just set your lower bound as 2 and your upper bound as a high number. If you're using the ClassWiz, you need to do this as 1 minus the probability of x is less than or equal to 1. Now, just a reminder for those that might want it, if I was, why is it less than or equal to 1? Well, let's have a look. Greater than or equal to 2 is anything 2 and above, okay, as represented here. So just this number line represents the discrete values that this could take, 0, 1, 2, 3, 4, all the way up to potentially 20. But greater than or equal to 2 is going to be anything that I've just labeled here. And you can see I've just corrected my labeling. So x is greater than or equal to 2 is represented here. Now, that means because the ClassWiz calculator only works with less than or equal to, we can find the probability of x is less than or equal to 1, take it away from 1, and we have the result that we're after. So what is this probability that x is greater than or equal to 2? Let's do it on the calculator very quickly. So number of trials is 20, probability of success 0.0033, and the probability here is 0.0027, and I've used 4 decimal places there. So there is a 0.27% chance that 2 or more are classified as genius from this test. So that's a review of what we've learned so far about the normal distribution and a little bit of an indication of what you might be asked in an exam situation. So now we'll get into the inverse normal. And here we have a situation where we're given a probability and we're being asked to find a value. Now, a lot of people look at the notation for this in particular and start to kind of panic, or what's this x less than a, that sort of stuff. But what I can tell you is draw your sketch and find on your sketch the area that you're interested in. Okay, so for this first part, we've got normal distribution, mean 20, variance 3 squared. The probability that x is less than a has got to be 0.75. So the first thing I'm realizing here is that this probability is more than a half. So if this probability is more than a half, what it means is that the value that I'm interested in, this a value, is actually going to be to the right of the mean. Okay, because if we're looking for the probability less than, that's the probability to the left of that value. Okay, so it's the cumulative probability, the area under the curve, all the way up to this number a. And because it's 0.75, bigger than a half, it means we've gone all the way past the mean and we're over to the right of the mean. So let's shade it in, as we always do. There's the area that I'm interested in. And how do we do this? Right, so we get the calculator and we work on what's called the inverse normal. So for the ClassWiz calculator, again, we're going to go menu 7. So this is for the ClassWiz. So we've got menu 7. We're going to go to option 3, and that's called the inverse normal. Okay, so the inverse normal is working backwards, isn't it? And what we've been asked to input is 3 things. We've got area, we've got sigma, and we've got mu. So when the ClassWiz is talking about area, it is talking about area to the left of the value. Okay, that's what the ClassWiz always works on, area to the left. So in our case, we can see that the area is 0.75. So we can type that in. Our sigma value is 3, because remember the variance is 3 squared, so the standard deviation is 3. And our mu is 20. And we press equals, 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 and then we find that a is 22.02, correct to 2 decimal places. Now a quick check to see if that number makes sense. We're expecting a number greater than 20, and that's what we've got. So for those using CG50, what we're going to do there is, and I'll just get this all set up, we're going to go menu 2 and F5 distribution. we're going to go F1 for normal, and we're going to go this time F3, which is labeled like this, inv n, inverse normal. And then we've got a number of options, okay? Our data needs to be variable. I don't think I said that in the last video, but the data needs to be variable. Now, the interesting one here is tail. This is where the CG50 is different to the class width. You can choose whether to do the area to the left of a value or the area to the right of a value. And each end of the graph, as it tends towards the asymptote here, we refer to as the tail. So what we're looking at here is the left tail, because we want the left-hand side of the value. So where it says tail, you're going to switch that to left if it's on right. So just make sure it says left. And our area is 0.75. Our sigma value, as before, is 3, and our mu is 20. And we get exactly the same value, which is good. So there we have it, okay? This is the inverse normal. It's starting with the area. The calculator then works backwards and finds out your value. So let's clear the writing from the screen. You can go back and pause it if you want to see any of that again. This time, the same distribution. So let me just sketch that back in. And we're interested in the probability that x greater than a equals 0.4. Okay, so again, this time we just have to take in this information and we have to get this a value in the correct place. Now, greater than means that we're looking at the area to the right of a value. Okay, so greater than a means we're going to be shading into the right of a. The probability is 0.4, which is less than 0.5. So again, actually, our a is going to be to the right of the mean. The reason it's to the right of the mean is because if we're considering the right-hand side of the mean, the area to the right of the mean is 0.5. We're interested in a smaller area than that, 0.4. So here is the area in which we're interested. Okay, I can identify that by putting a little arrow and saying this is an area of 0.4. And then we go back to the calculator. Okay, so for the class whiz, this is where you guys have to do a little bit of extra work. The class whiz always works with the area to the left. Okay, so you have to do a little bit of maths first. So if the area to the right is 0.4, then stands to reason the area to the left is 0.6. They have to add up to 1. So on your inverse normal, in the class whiz this is, you're going to type in area 0.6, you're going to type in sigma 3, and you're going to type in mu 20. And when we do that to 2 decimal places, a is equal to 20.76. And again, that's correct. It's to the right of 20, which is what we were expecting. So for anyone who's using the CG50, this is where your tail option comes in handy. So this time we're going to set the tail to right, and all of the rest of the details are the same. Area is 0.4 from the question because we can type in to the right. Sigma 3, mu 20, and we'll find the same a value, which I've just confirmed, 20.76. So it does depend on your calculator, but it's obviously very doable. Okay, just remember, if you're using the class whiz, you're always working with the area to the left, and you have to remember that. You have to remember that, and that's where the sketch really comes into its own. Okay, so let's then have a look at the final question, where we're being asked to calculate the a value again, but this time we're given slightly different information. So here's my 20, here's my sketch. So x is between 16 and a. So let's mark that in. 16 is less than 20, so it's over on the left-hand side here. And we're not sure where our A value is. Trying to get that straight. There we go. There we go. Saying today. Yeah. And we've got 0.3. So I mean, for the sake of it, I'm going to put the line over on the right-hand side. We don't really have a great deal of information to help us with this, but it's a good place to put it, right? So we'll say we've got 16 here and we've got A here. Now the area that we've been given is the area in between these two values, all right? And it's 0.3. So what we can do is we can just kind of work a little bit actually thinking there. Oh, hold on, someone's come to the door. Okay, so as we were saying, to find this value of A here, we just need to think a little bit outside the box. So what I can do with this, right, something I know that I can do, is I can calculate the area to the left of 16 without any problem, all right? So it's going to be a little bit more work here, but let's do that. Let's find the area of x less than 16 using our straightforward normal distribution, as we learned in the last lesson. So menu 7, normal CD, which is option 2. Lower, we're going to make a very small number, minus 100,000 will do it. Upper is 16. Sigma is, what was sigma again? 3, I think. And mu is 20. So the probability to the left of 16 is 0.0912 to 4 decimal places. Okay, so that's this area, 0.0912. Now that means that the probability of x being less than A is 0.0912 plus the 0.3 from the green area. Okay, so to the left of A is this area combined with this area, so it's these two areas together. So what we've got is the probability that x is less than A is going to be 0.3912. Okay, just added those two together. Now we can use the inverse normal function. So we'll go back to menu 7. We'll choose option 3 for inverse normal. This is on the classways. The area now is 0.3912, and the sigma is 3 and the mu is 20, and so we end up with A being equal to 19.171. So we see 19.17 correct to 2 decimal places. Now, as you can see, obviously I got my value of A in the wrong place. It should have been to the left of the mean. But it doesn't matter, actually. You're not being marked on your ability to sketch this graph. The graph just helped me to figure out what it was that I needed to do to answer the question most effectively. The fact that A comes out as 19.17 is fine. That is the correct answer. So I'm moving on to the final example for this video. We'll have a look at this question. We'll just get into it, shall we? Plates made using a particular manufacturing process have a diameter d, which can be modeled using a normal distribution where d is modeled as a mean of 20 and a variance of 1.5 squared. Given that 60% of the plates are less than x, find x. So very similar to what we've just done. Okay, this time it's a wordy question. That is the only difference. So let's put in our mean, 20 again. There's our normal distribution curve. 60% of the plates are less than x. So where are we going to place our x value? It's going to go over here to the right, because the area that we've been given is bigger than a half. Here it is, shaded in, 0.6, 60%, which means that here is my x value. Okay, so it's bigger than 0.5, so from the left up, it goes past the mean, and that's where x is. So now that I've got that visual representation, let's find out what we've got. So we know that the probability that x is less than little x is 0.6. Again, using the inverse normal function on the calculator, We'll go back and we'll say the area is 0.6. This time our sigma is 1.5 and our mu is 20 again, and we've got 20.38. So we've got 20.38 centimeters. Now you need the units. Whenever you're asked a real life question, a real world question, you need to include your units as part of the answer. So let's get into part B then. This is where the interesting bit happens. So I'm going to draw another sketch, okay, separate sketch this time. It's still the same distribution, nothing's changed. So here's my lovely bell curve. There's my mean of 20. And now we're talking about this, the interquartile range of the plate diameters. Now this is about your understanding of interquartile range. And I hope you have thought about interquartile range in these terms before. But if you haven't, this is going to be a learning journey. So the interquartile range is the measure that takes the central 50% of the values. And when I say central 50%, it means that if I shade this area between these two values, the area that I've shaded in red there is 0.5. Okay? And we've got two different ways of doing this depending on the calculator that you've got. So in order to make this really clear for both, I'm going to shade in green here my either tail. So either tail is going to be 0.25 and this tail 0.25 as well. So that interquartile range means it's the middle 50% of the data, and so we've got the lower 25% here and the upper 25% over there. We've got x, call that x2 and x1, just so we've got from left to right, and we're just trying to find out what those values are. So you've got a couple of different ways you can do this, all right? On both calculators, what you can find out is the following. So you could say, what's the probability x less than x1 is going to be equal to 0.25, and you can use your inverse normal to work out what that x1 is. So let's do that. We've got area 0.25, sigma 1.5 again, mu 20, so we've got 18.99 to 2 decimal places. And then what we can do is we can say, well, the probability of x being less than x2 is 0.25 plus 0.5, which is 0.75. And so we can find out x2 using that logic. So we can say 0.75, keep the rest the same. We got 21.01, 2 decimal places. So the interquartile range, which is what we're actually asked to find out, is going to be this 21.01 minus the 18.99, which is going to be, back to menu 1, 21.01 minus 18.99, 2.02 centimeters. And that's how you would do that question on a ClassWiz, but you can also do it on the CG50. So on the CG50 though, what we can use in our inverse normal is quite interesting. When you select the tail, instead of opting for left or right, you can opt for central. Now what that means is it will find a value on the left of the mean and of the right of the mean where the area is split equally between them. And what I mean by that is, for example, in the previous question, when we had an area between 16 and A, we didn't know that this 0.3 was distributed evenly across the mean. In fact, it wasn't at all, right? And we couldn't know that from the question. From this question, we can know that because we know that the interquartile range means that the 50% in the middle is split evenly across the mean. So if you change your tail to central and then change your area to 0.5 to represent that 50% in the middle, then you've got your sigma value of 1.5 and your mean of 20, you get the two values, all right? You get the two values at once, 18.99 and 21.01, okay? And then obviously you do need to do the last part, which is to subtract one from the other. Now you don't need the centimeters necessarily here because they're part of the working, but you certainly do at the end. So that's how to use your inverse normal function on your calculator, and that's when you need to use it. In the third video, I'll be looking at approximating a binomial. Oh no, sorry, in the third video, we'll be looking at calculating mu and sigma. So, see you then. Thanks very much.